With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Figure shows a block kept on a rough inclined plane. The maximum external force along the plane downwards for which the block remains at rest is 1 Newton, while the maximum external force along the incline upwards for which the block is at rest is 7 Newton. We have to find the coefficient of static friction. So what the question is saying is, there is some friction involved here. There is some friction, and now this friction is quite strong. So not only does this friction prevent this block from sliding due to its own weight, but also when you try to push this block with a force of 1 Newton up until 1 Newton, this block does not slide when you push it downwards, and up until 7 Newtons, when you push it upwards, the block doesn't move. So using these information, we have to find the coefficient of static friction. So let's see. Its weight is going to be acting downwards, mg. So there will be the component mg cos theta is equal to mg cos 30 degrees is equal to root 3 by 2 mg, and there will be a component mg sin theta, which I can write as mg by 2 because sin 30 is 1 by 2. So now let's consider the frictional force that is being involved. So the frictional force, no matter in which, I'm not talking about the direction right now, only the magnitude. So the frictional force will be mu times the normal reaction that the block is putting. So mu times mg cos 30 degrees, which means mu times of root 3 by 2 mg is the frictional force. Now when you're pushing it downwards with 1 Newton, when you're pushing it downwards with 1 Newton, the frictional force is going to act upwards. So if I try to balance the forces along this axis, that is along the incline of the plane, so 1 Newton plus this mg sin theta, that is mg by 2, should be equal to the frictional force, that is Fb, which means 1 plus mg by 2 should be equal to mu times root 3 by 2 mg. Let's mark it as equation number 1. Now when you are pushing it upwards with the force of 7 Newton, the frictional force is pulling it downwards. So once again, if I try to balance it, what will happen is there's 7 Newton which is pushing upwards, and then there is the mg sin theta component, so mg by 2, that is pulling downwards, plus the frictional force, which means 7 is equal to mg by 2 plus root 3 by 2 mg times mu. So this is equation number 2. Now I can make a substitution from equation 1 to equation 2. If I look at equation 1, mg by 2 is equal to mu times root 3 by 2 mg minus 1. So if I make this substitution into equation number 2, what I get is 7 is equal to, I'll replace mg by 2, so mu times root 3 by 2 mg minus 1 plus mu root 3 by 2 mg, which means 8 is equal to 2 mu root 3 by 2 mg, which means mu times root 3 mg is equal to 8. Let's mark it as equation number 3. Now let's substitute this value into equation number 1. So equation number 1 was 1 plus mg by 2. 1 plus mg by 2 is equal to mu times root 3 by 2 mg. So mu times root 3 mg is equal to 8 newtons. So 1 plus mg by 2 is equal to 8 by 2, which means mg by 2 is equal to 4 minus 1 is equal to 3 newtons, which means mg is equal to 6 newtons. Now I'll put this value back into equation number 3. So mu times root 3 mg is 6 newtons. So 6 is equal to 8, which means mu is equal to 8 upon 6 root 3, which means mu is equal to 4 upon 3 root 3, which is our answer. So option number D.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.